managed to deal with issues. So let's kick the session off. So my name is Darko Pilav. Lovely being here. I work at Digital Asset, and at Digital Asset is a technology provider. And with our technology underpins a platform that allows to build a digital ecosystem for financial services. And what we actually mean by that is that we have a number of various customers of different sizes across the globe and across the financial markets that have built various applications and services on top of our technology. And what they now can do with our technology is start to interoperate and interact with each other. So these applications can interact with each other. But now let's go back to kind of the main talk that we want to cover here. And one of the first question that I want to pose, it's actually the same that Cecilia did in her keynote, which is, why do we actually need digital money? Isn't what we already have good enough because the current world works? And yes, it's absolutely the case that the digital money is going to provide immediate improvements in various spaces. It's going to provide more transparency and resilience, remove the need for reconciliations and all of these things. However, if we stop there, then we're actually missing on a huge breadth of additional opportunities that where digital money can actually provide benefits. And namely, if we're just thinking about improving money transactions, then we're literally just looking on one side of the story, or just looking at one half of the story. Namely, there is always another leg to the transaction as well, right? We're always making payments for something, because we're buying something, because we're paying for some services. And effectively, when we're thinking about digital money, we should also be thinking about connecting, or what we're calling composing, the reasons why we're paying with the payment itself, such that it can be guaranteed that either both things happen or neither does, and through that remove risk. So effectively, with that, we can achieve true delivery versus payments and atomic transactions without trade-offs. And effectively, we do that through the composability of applications across different networks. So let's just kind of take a quick step back and look at how some kind of DVPs can be achieved or are being quote unquote achieved nowadays, and kind of what are the different approaches there. And in general, when you look at traditional finance, you always require some kind of orchestrating party in the middle of such transactions. In this particular case, let's just look at DVPs. So you always need some kind of orchestrating entity in the middle that is making sure that both legs are happening. And there are a couple of, and then with the introduction of distributed ledgers, the idea was that you could actually kind of remove that orchestrating entity, but then as soon as you have cross-chain or multiple chains and various applications on those different chains, then you're introducing that need for orchestration again. So a couple of ways how things have been done or could be done is with the CSD model. So there is just kind of a settlement agent in between that is orchestrating the movement of cash and the movement of the asset, and kind of in the real world, the cash moves first. As soon as it's done, then the asset movement is being instructed. And of course, kind of purely by talking through it, we see this is not atomic. And there is also an entity in the middle that needs to have a fair ton of trust and is seeing a lot of private data in the process as well. So the next thing would be kind of technology bridges. Hash time lock contracts is a term often used in that context as well. And there you would have two separate solutions that are independent of each other, mostly independent of each other, and then a bridging solution that is put in between and that connects these two applications. But with technology bridges, First of all, you have an operator of that technology bridge. There also needs to have a certain amount of trust and operational trust at least, and probably also transactional trust. But then you also need to coordinate between the applications such that you can build these technology bridges. They need to have a common API almost, or kind of some common app logic that deals with these bridges. And also, as soon as you start thinking about adding a third application to it, then you need at least 2 more bridges, and just kind of it doesn't really scale really well. And I'm not saying that tech bridges are in general a bad solution. I would say that they are absolutely required when you want to interact across technology solutions. But what is also the case is that you want to get the best properties possible for these kind of DVPs, and there are better ways of achieving that than through simple tech bridges. Just 2 more things, custody bridges. So in contrast to technology bridges, this is more kind of a bridge on a business level where an entity, an intermediary is present on both solutions, and then you pay money to that intermediary. That intermediary then represents that cash on the let's say the asset solution ledger, and then you can do a pseudo DVP. It's pseudo DVP because you are doing an asset versus not really cash, but a cash representation that is being managed again by an intermediary and a trusted third party, and so on. And then finally, kind of real transactional and atomic interoperability. And you can do that kind of in 2 ways. On one hand, you just put everything onto a single ledger. This is kind of the initial idea. And you can absolutely do that, but the problem is that as soon as you put something on a common ledger, these things to a certain extent also need to have some common governance of applications, or you lose some sovereignty as an application provider, as a service provider. You cannot just kind of decide what happens with your application because it's living on a broader network where other things are living on as well. Not so with Canton. With Canton, you really have separate networks, and each network is dealing with a particular application, and then you can still do atomic transactions, protocol-level transactions, what we're calling on it. So we're going to have a look at this particular use case in the demo, so delivery versus payment. And this is what we're going to see. We're going to see 3 different applications. There is going to be an asset tokenization app where we're presenting some kind of tokenized asset, a digital cash app with its own separate network where we are representing some kind of deposit token, and then a trading application that is tying these things together. And in principle, kind of what is special about this approach is that you can have entities that are linked to multiple of those applications at the same time with the same infrastructure. And then with that, they can actually do these atomic transactions. So let's switch over to the demo. And the way I've set this up is the following. First of all, let me increase this. No, that's good. So here you can see there are 3 different kind of colored areas in my browser. The first one contains 3 tabs, and this is the, unfortunately you probably can't see it on the screen, but this is the asset tokenization application. Then we have the cash application, and then the trading application. And it's always set up such that the first tab is the service provider of that particular app. The second app is the investor 1, and the third tab is the investor 2. And it's the same for all these. So this is kind of the asset tokenization app operator. This is investor 1 for the asset app, and so on. And what we're going to, the way it's currently set up is that on the asset tokenization app, Investor 1 and Investor 2 have set up accounts, and if we look at the holdings, investor one is holding 1 million units of an asset called bond. It's just kind of a generic asset that we've set up there. And it's a completely sovereign and separate application that we are running here. On the other hand, we have the cash side. Again, investor one, investor two have accounts here as well. And we can see that investor two has $1.25 million US. And in the trading application, investor one, investor two are simply participants. So effectively, kind of to go through all of this, the investor one would be creating a RFQ, a request for quote, saying, kind of naming this. Let's say this is bond versus USD. And it says, I want to sell 250,000 of my bonds versus US dollars. And I actually want to ask a particular investor, which is investor two. I want to ask investor two to provide a response to that quote. So with that created, the investor two can see that there is an request inbound, and it can accept and say, okay, I'm willing to buy these bonds for $1 a piece. Back to investor one, we're still in the trading application. They see that there was a response. They can have a look at it. They can accept it. And we're now good to go go into the settlement aspect. Now, what is important here to mention is that, as I said, these three applications are completely independent of each other, which means that the asset tokenization app operator and the cash operator have no clue that any of this is happening. They don't even care about it. All of this is being done by the trading application. So we can then create the settlement instructions and quickly go through the settlement process. So investor one needs to say, okay, I'm actually willing to allocate 250,000 of the bond, and investor one needs to say, I'm fine to receive that, and I want to receive that on the following account. You need to tell that to the asset tokenization application because, as mentioned before, the asset tokenization application doesn't know anything about the agreed trade, so you need to provide kind of approvals for all of that. And quite similar on the cash side, investor two needs to agree to approve the payment, so it's going to allocate the 250,000 US dollars, and the investor one is going to say on to which account the money should actually be paid. Now this has all been done, and now we can simply atomically initiate that transfer. So far, only allocation has happened, so both the bond as well as the money have not changed hands. And now with the push of a button, we have true atomic execution of that transaction. So if anything would have gone wrong in one, the other thing would have not have happened, although they are separate applications. So looking back here in the overview, we can see now that investor one doesn't have 1 million bonds anymore, but 750,000, and investor two has 250,000, and the same movement you can see on the cash side. So one thing to mention here is that if we wanted to add, for example, another use case where there is a margining use case, for example, the cash application wouldn't need to change at all. There's nothing that would need to be provided there because all the required features like pledging and doing a transfer are already there and can be leveraged by other applications that are composing the cash application with the margining application. So that's quite a crucial point. So in principle, what have we actually seen? We have seen 3 completely sovereign applications that can move at different speeds, and this is actually what has happened during development. We have developed these 3 capabilities at different times, independent of each other. Each of them is running on their own network, and through the composition of the workflow, we were able to do an atomic transaction without trade-offs. And effectively, if you have that and you're able to scale that out, you actually can build a global economic network. Thank you very much.